Hello everyone, welcome to the bike sharing system presentation, the final presentation. So let's start. So first we look at the overview. We look at the bike sharing system overall case scenario, the summary of the bike rental process, the information systems architecture, the components of the information systems architecture, information security risk analysis, data dictionary, the Python code implementation, SQL relational database and its use case, summary, and its references. So let's begin. So we first begin by looking at the case scenario. The case presented to us was with a task to build a bike sharing system for a medium-sized city based in the United States. We came up with a solution for using a web application for the user to initiate the process. And as we know that there are two subscription models available, that is the annual membership, which is at $70, or a daily pass at $5. Next, we look at the bike rental process. So the user initiates the process by registering their information on our web app. This includes their personal information as well as their payment details. Once the payment detail is authenticated, they can look at the bikes that are currently available near them using the Google Maps API data. On the back end of the software, we use an ERP system, which is an enterprise resource management system, to connect the web app that keeps a track of the customer data and helps bill the customer on the usage. Additionally, it helps us automate certain aspects. We use API to help connect our web app to Map API, Payment API, and Ride Metrics, to name a few. Now let's look at the information systems architecture. So the bike sharing app is a web since it's web based. It is best to integrate it with Google, and using it to using Google's technology, we can use it to compute, store, do data analytics, artificial intelligence, networking, and use it even towards developer tools. um, One really good thing that I really enjoyed is while learning, the entire structure is that we can use a single sign-on where the user logs in. The payment can be done through a payment API, and then of course bike rental, the person's ready to rent a bike after the payment has been verified. Next, we look at the components of the information systems architecture. So it is a Google. So the Google Cloud stores all our information regarding the availability of bikes, the customer information, and the payment information. There are bike stations, which is the physical locations for the users to pick up or return the bikes at. The station updates in real time when a user interacts it with the bike or the portal or the web app. The ERP software, which is connected again to backend to the Google Cloud, like we said before, it tracks the ride status, it manages customer accounts, and it generates reports for the management team as well as the information systems administrators. Next, we look at the network infrastructure. We require a lot of servers, routers that connect to the central cloud from the bike station. So for this, we even need to install, for safety purposes, we can do a firewall. We can install, online antiviruses, things like that. But of course, when you're using a cloud technology, these things are kind of taken care of. So uh, that's why we want to use the cloud-based technology. Next is, of course, the user interfaces. I believe you cannot see this on the screen, but I will read it out. The web app, that is easy. The web app, when you use the web app, you can unlock the bike, and of course, you can perform tasks such as updating your contact information, updating your payment information, or you can share your status with somebody else, things like that. So the user interfaces is very important because a person can, you can use it has to be user friendly for everybody to use because it is easy for us to order the bikes. So that's a very major component in terms of the information systems architecture. So the information security risk analysis, we came across five of them, which was the first one being data breaches or cyber attacks. Now this is common in today's date. Most of the companies face a lot of problems. We've seen issues with American Airlines. We've seen issues with Walmart, Target, things like that. So it is beneficial that we can take a look at something like this and kind of have some precautionary measures for it. Secondly, is loss or theft of the physical bikes. So, in order to kind of tackle this problem, we can install, like CCTV cameras, where the bike stations are present at, and of course, those can be monitored and triggered. Um, and another thing that I could say in terms of solution is that uh, whenever we have like a physical location, we can have like silent alarms if somebody's trying to tamper with the lock, or they're trying to have an unauthorized access to these bikes. Then it can be like a silent alarm can be triggered, where a 911 gets an alert and somebody can come and take a look at it. Third is of course system downtime, which is again, since most of our work is based on web app, it can be that Google servers can go down. Nothing is 100%, but of course, the pros outweigh the cons, so that might be a risk as well. Fourth is user accidents or injuries. For people who are first time, they're using a bike on the road, they do not know the rules and regulations. We need to kind of update our own internal policies. If we can add a cost of like insurance to the bikes as well as the people who are riding them, that would be kind of nice, that you can offer that as a value add-on package for them to buy it. um, Fifth is, of course, fraud or abuse of the system through hacking. Like I said again, unauthorized access. You can have silent, alarms that can trigger either alerting the authorities, or it can alert us as network administrators, and we can kind of go back and look at if somebody's trying to hack into the system, or into the portal, or is it like somebody who's trying to physically harm, the bikes. Moving on. So here is a data dictionary that I used in order to create the code for the Python code that is going to come up next. So we look at the first thing is the user registration, which is really important in the overall bike system. So we look at the fields such as first name, last name, user age. If the person's under the age of 18 years of or age, we cannot lend them a bike, things like that. So a unique user ID, email ID, phone, subscription type, that is the annual or the daily pass, a payment charge, of course, a credit card that's on file with us, and of course then, oops, I'm sorry. Yes, to calculate the cost of the ride, we look at the pickup time, such as like the pickup time, the drop time, the subscription type, again the subscription model that is used, the annual pass, the daily pass, the ID, the email, phone, subscription type, the total ride time that's taken, the difference between the pickup and the drop time, that's your ride time. And then of course the generation of the bill, so based on their subscription, what is the amount that is charged, and then of course the payment that is charged to the account. So next we look at the Python code, and I'll try and explain how it works. So if you look at the code implementation, this is the Python code that's written based on the variables of an annual subscription and a daily pass that was provided to us in the start of the case. So if you look at it, down here in the black box down here, we can see that what kind of subscription type it is. So one is, of course, it's going to be for, like, you can read over here, like enter one for annual subscription and then enter two for daily subscription. So the first type of subscription is of course the annual subscription, and then it talks about what day of the week it was, then uh, day number, and then pickup time or drop time, and then of course I did like 6 minutes and then 700 minutes. Of course, the annual subscription cost is $70, but the ride cost came up to $57. So you can see all of that code down here, which is a screenshot that I took from the code that I wrote on the Python compiler. Um, so now let's take a look at the SQL relation database. So a database has to be attached to, either the ERP systems or the cloud database. Either ways, it is extremely important for us to have it because user information is stored in tabular forms. Based on the user ID, on the age, and the name, the location that they picked it up from, things like that. So SQL statements allow us to retrieve, manipulate, or delete data that are stored in relational databases. We will write a SQL script to compute the average ride duration for a user, compute the number of bikes that are checked out at a given station, and to retrieve the list of active users in real time, followed by data dictionary. So I've already shown you the data dictionary before, like I said, but here we take a look at one of the use case scenarios, which is the number of bikes that are checked out at a given station. So if you look at the SQL statements from the data dictionary, that is the bike ID. So we can select the count of the bike ID and from the bike, and then from which bike station, from where the bike was picked up at, and then of course what is the bike. So bike station could be 10. So if you're in a city like Kansas City, you can have about like 25 stations around Plaza, around Parkville, around different areas around downtown Kansas City. So every station ID is unique, and wherever it is picked up from, we can take a look. And then of course the status being zero is it's not active, or it is active based on zeros and ones. Um, so let's go on and take a look at the summary of the overall system. So in the summary, the last steps of a sharing system may involve returning the bike to the station, of course, locking it in the station, ending the session, and leaving the bike at the station for the next person to use. The system may also have a mechanism in place to monitor the status of each bike. Like I said, we are using cloud technology, so this is done in real time. So if you again look at the summary of the overall bike system, the user logs in, there's a payment verification that's done through his card details. The bike rental begins. Of course, the bike is rented out. The ride time calculates based on the Python code, and of course, calculating that ride and sending out. And then, of course, the last step is the user gets the receipt of the usage. When the user goes and drops the bike, he gets a receipt of what has been used, and that is basically the end of the ride right there for the next person to use. So that is basically a circle that life cycle. I mean, it's like a complete circle of the bike sharing process and the system. My references are from the Information Systems for Business and Beyond, Deloitte Incorporated Technology and Legal Department, IBM, SOA versus microservices, what is the difference? Information Systems Related Security Lists, glossary from CSRC, Bike Management Software from Frontline Public Safety Solutions, Electric Bike Rental Software from Electric Bike Manager, Google Cloud Computing, Python, the program, and Microsoft MySQL. And thank you so much for watching.